Hello everyone, I hope you all are doing well. So, in this session, I came up with the ANSYS Fluent. Here we'll consider the simple model that is bus into account and we'll just go with the basic steps of ANSYS Fluent to calculate the drag force if you're looking for lift and coefficient of lift as well. Okay, so this tool is quite simple to use and let's see how it can help us to just deal with the same thing. Let's get started with this. So we'll start with the ANSYS Fluent. So you can just drag it and you can just name it like this. For my safety purpose, I'll save the file directly because uh, while dealing with the analysis, it got crashed multiple times. So every each and then it's better to save the file or save as copy to save your data. So I'll browse the file. I'm going to use only bus. I need to conduct this series of analysis here, like only bus with camera and with a mirror. So in this geometry, I'll use the design modeler instead of space claim. Space claim for me it is quite complex. I don't like it. So you can use the simple tool that is design modeler to deal with this thing, and if you want to design or if you want to make some complex modifications, you can use other tools like SolidWorks that I do. Yep, so the model is here. You can simply generate it and you can change the unit system to millimeters, and now I need a plane, so I'll create a new plane with respect to XY, and XY plane is somewhere here, right? So it is quite difficult to deal with this, remember. So along XY plane, so I'll use the offset along Z direction, isn't it? So here you can specify the value 1000 is inside, so 5000 if I take it, 500 is coming inside. Again you can add the minus value to take it out. I'll try with 100,000. Yeah, so this is quite big, so minus 500 is fine. Yeah, this is okay. So the plane is ready. I'll generate this plane, and on this plane I'll sketch. You can use the sketch tool and you can switch to this. Look at this, and now switch to sketching tab. From there I'll simply draw a rectangle like this. Approximate. I'm just dealing with the course analysis, not the accurate analysis. Yep, the sketch is ready. You can go to extrude and just rotate the model. Value 2500. Okay, it should be more. 4000. Oh, quite more, right? Let me reduce it. 3000. Yep, so this is fine. 3800. Generate this model. So could see there are two solid models, two bodies are available, so I'll use the boolean operation to remove one of this. I'll change the operation to subtract. Target body is no, from here I can't, so I'll use the drop down. So this is the target body. Tool body is this. If I generate, okay, I need to reverse it. I'll delete this boolean. Remember that we need to define the proper target and tool body. So subtract here. Target body is this recently created, right? And the tool, yep, and the tool is this. So this should be removed and generate. Now to check this, you can use the section plane. Edit section it is. You can use this new plane. Orient it like this. Just remove it. This is fine, no issues. You can just turn it off, or if you want, you can delete it. The model is ready. Quite simple one. So design modeler is quite easy to work on, but when it comes to access space claim, you need to take that into account to work on your model, to repair it and to add the enclosure for the complex models and all, to remove the extra adjacent edges and faces. There are so many repair modification things and all you can do it. The answer space claim is advanced to deal with these kind of things, remember that. Okay. Yep. So yep, once it is done, you can go ahead with the meshing. So in the mesh tab, it will again open the new workbench. So this time again, I'm going to use the normal coarse mesh, not the appropriate mesh, not the proximity curvature, which is very fine. Can use the inflations and mesh methods to mesh your model with accuracy. But in this tutorial, I'll just cover the basic meshing. Yeah, so in the mesh tab, it is format is standard, element order is linear, solver preference is Fluent. According to that, it will take the values into account. And when it comes to sizing and quality, I need to modify a few things. Yeah, so in the sizing, you could say it is curvature, relevant center I'll change to medium. Size function curvature, not the proximity and curvature, so that will again define your mesh too much at the curvature regions with respect to proximity. So remaining everything, I'll keep it as it is, not going to change anything. You can even deal with the quality types and advanced things and inflations. If you want to add, you can even add it. Okay. Yeah, once you run your entire mesh, so you'll get the meshing output. As you could see here, could see the mesh and you can analyze it. This is quite okay, you know. For me it is fine. So with respect to the requirement, this mesh is for me okay. Yeah, so once your mesh is done, you can go ahead with the next things, that is creating the name selections for the Fluent to recognize the inlet, outlet and the wall. This, the front face, you can just right click on it and you can use the create name section or selection. It is inlet. The same thing at the behind this should be outlet, create named selection, and here it is outlet. And all the four faces are kind of wall. Element is outside wall, for my understanding. Okay, software like the answers will automatically recognize these things, you don't need to worry about it. Now I need to select all the whole bus model, right click and select all, and now hold the control and unselect one and all, not needed. These and all I don't want. Whole body I wanted, so simply hold the control again, right click and create name selection. It is, I can name it. Limit as bus model surface wall. Okay, so this is fine. Yes, name selection is also ready, so you can simply update the mesh and you can just save this. You can run the setup after this. I repeat, better to save your model every time. I'll use the double precision parallel method. I'll use it if you are going to deal with, sorry, series I'm using. Parallel, if you are going to use, you need to define the processor and the number of cores which you are using. So you can even select that. It is quite fast. Yep. So ANSYS Fluent will load the initial steps like the general things and all the mesh and each and everything, the inlet, outlets, and so on. So once you do that, I can able to define the gravity and units and even the time frame. If you're running the STD analysis, you can select the STD. Remember that if you're going to run the transcend analysis, you can select the transcend and define the time frame. So this is what you can do it in the initial general tab. So let me just activate the gravity along y. It is minus 9.81 meter per second. Velocity kilometer per hour. Close it. 2 seconds square it is. Yes, this is very important in the models. I'm gonna select the viscous model as the k epsilon. Okay, question 2. And instead of realized, I'll use the standard one. Okay, can select any one of these things depending upon your requirement. You can go ahead with that. Next thing is to material. To check these things, you could see the fluid is there and the material is aluminum, cell zone, and the boundary conditions here. Inlet should be the air, it is there, so it should be with respect to 100 kilometers per hour. So the air is moving like this with respect to that. I need to find out the drag and the coefficient of drag value here. Yeah, so next the reference values. I'll initiate from compute from inlet. This area, so this is the frontal area. If you won't define it by default, if you keep it one, no issues. Remember that. You can even go to this projected areas, and from here you can copy it. It is 25.026. And this is a shortcut to just access this. I don't need to worry about this much, so you can even keep everything default and you can run it, no issues. Oh yep, so next thing is to deal with the reference values. It is done. Next thing is solutions and the method. The scheme is simple. Turbulence, kinetic, and I'll change it to second order upwind. Okay, the residual stress, I'll add it. Force is drag, drag force. I'll take it as drag force only. I'll name it. I can activate the wall, so I'm gonna use the whole surface body, right? Yep, so you can add the report plot and the report file, and even you can include the print console so that it will print everything in the console. At the bottom you could see just below the model, the mesh model, you have the console, so activate that as well. So I had already done that. So it is cd track coefficient, activate report file and the report plot and the print console as well. So here I forgot to mention it, so you can later on do it. Here the residual stress, you can set the accuracy to 0.001 or 0.1 raised to minus 6. Can able to mention it so that you can get the better accuracy. So I'm going to initialize with respect to standard or hybrid, depends. Okay, I'll start with the standard. I'll compute from inlet. You can initialize. So once you do that, you can directly go ahead with the running the more analysis. So I'll run this entire calculation. A number of iterations you can set it. I'll take it as 100, interval 1 and 1, or you can increase it to interval every 2 to save the time, and calculate. So it will initialize, it will run the case, and then it will start calculation. So it will take some time. Yeah, once the setup is done, you can run the solution. So double click on it to load the solution, and you can even run the results. What I'll do is I'll accept the interrupt because I tried only the 100 iterations. So due to the convergency, the straight line in the CDs and CL, so I took only this much. So you can just accept this one and you can go ahead with the results. So I'll just double click on the results to view the results for the same thing. You could see everything is blank. It will take some time to load the entire model. With respect to the results, you could see we have the CFD module and the user locations and plots. For the CFD domain, you can turn on these are the reports. No use here. Can even check these drop downs. We have the file report and the mesh report and everything. So if we have this user locations and plot here, I'll activate the bus. This faces for our convenience. This is the outlet and inlet we have there. So I'm gonna just deal with the contour. The plane you can create it first, or else I'll just I'll start with the contour, and this I'll select the pressure and the module is plain. It is not working. I'll take the bus. You can even apply and check. Here with the bus, apply, and you could see this is the pressure contour plot. So as we expect, the pressure will be more due to the frontal area at that region. This is the wireframe. I'll turn it off for now. Yep, so this is the pressure plot. Now to draw the velocity plot, you can't select the bus only, you need to have the outside module. Remember that we are going to deal with the air, right? So for that you need to select the velocity of the air, not the body. So it will be 0 on the body, right? So I'll create a plane by using this user local definitions, and I'll use select this plane, and here plane 1, you can even rename it, and here it will ask you for the location. So along xy, at what distance you want it. Try with the preview. So if it is minus 0.5 meter, I'll activate this counter plot and I'll select the same plane one, and here instead of pressure, could say it is outside. No, let's see. Instead of double click on it and change it if you want. Let me just take this as a reference at the moment and I'll apply contours. You can increase it up to 200. Yep, I'll apply it and you could see it's completely black. So I'll just switch this particular plane to a certain distance. Minus 0.5, same thing. Default reset will come to the origin exactly near to this model, but here I don't want it. Let's see, we have the velocity plot proper, don't need to worry. This plane should be somewhere exactly at the middle of this bus. No, what I'll do is I'll change this value. Instead of this, I'll keep it minus 0.5. If I apply this, so preview it, okay, it is moving outside, so I'll take it 0.5 inside, apply. Yep, this is fine. So it should be slightly again inside. Only slight thing is enough. Instead of 0.5, I'll try something else. 1. Yep, so 1 would be the best here for our reference. You could see this is the velocity plot for the entire model. So you can even deal with the streamlines. You can activate it from the vertex. We have the options. So inlet you can select, or you can even select on the plane one. I need to turn off the counter 3. You can even rename these counters. Okay, counter 1, counter 2, counter 3 are there now. You can right click and you can just define the pressure float, velocity float and all. So that's quite simple. And this is the vector float, right? The velocity float. Quite easy, right? And quite attractive as well. So now I can try to deal with the factor. If I take 10, it is small, and if you increase it or if you decrease it, you'll get the more denser streamline floats. Okay, and these are the options: the color, render, views and all. You can modify whenever you want, and you can set it up to your requirement. Yep, so here you can even have this float counter 3, the velocity float, and this is the float, right? Can you even animate these things? I'll reduce the value to, yeah, 100 is fine. You can see that grayed out structure. No, this is why, because we have this plane is active. You can turn off the plane to avoid that things. So don't think that it's a software glitch or whatever it is. Due to that plane activation, it is like that. Okay. Now this is about the floats, and this is the trajectories and all. So now here we have the floats. You can simply right click on it. You could see we have this float. So what I'll do is I'll go to the report floats. The same thing, it has all the details: CD values, K epsilon values and drag values. So if you want to compute the CDCL values which are listed there, you can use this report definitions, double click on it, and you have the compute option here. So if you click on this compute with respect to the wall, it shows the coefficient of drag is 0.5, and if I consider the drag force, it is 6100 something. Okay, so with respect to the requirement, it is closely matching. And when it comes to the floats, finally I'll just glimpse it. You can just delete which and all you don't want. These are the pressure and the velocity floats, so which we are looking for. That's quite good and okay for us. And now this is the streamline. This is also fine. And we have the vector floats. You can even turn it on. Okay, if you want, you can hide the counter 3 float to just show the vector float like this. Yep, so the streamline is gone. Now if you want to animate these things, you can use this animate tab, and I can activate the streamline and try doing the same thing. The plane one, if you try, it will animate the plane same as we do in SolidWorks flow simulation. So you can even turn on the streamline, and you can start this thing. Let's say this is the ball. You can even deal with the options, and you can modify these things to 3D flash, or different options are there. The drop down, you have the options, and here you could see this is the format, and this is the symbols. We have these all the standards: arrow 3D, arrowhead 3D and all. So try with these things and try to animate and render the videos for your marketing purpose. Yep, so this is quite easy to use, and if you just go through this particular complete session, you could able to analyze how to deal with the ANSYS Fluent to deal with the CFD analysis. Yep, so that's all about this session. So in short, we had covered ANSYS Fluent module with basics, from basics to advanced level, what and all we need to do, how to just create the module and how to subtract the uh, model for the CFD analysis, and defining the boundary conditions and meshing the model according to the requirement by using the proximity method or curvature method depending upon the requirement accuracy of the mesh. And then after that we had gone through uh, process definement, name selections. Once that is done, so there in the general you can define the gravities and all, and then the unit system, and then define all the boundary conditions like inlet velocity and all, and then define the model. So k epsilon model we had taken. So once that is done, so what and all the result you are looking for, you can just define the definitions for drag and coefficient drop, which I was looking for. I had just extracted the same thing, and then initialize the model with respect to the input and take the frontal area as a reference, and then finally review the results and compute the results like CDCL values and other things, and finally preview the results by using the report options. Okay, so conjugating the streamlines and even the uh, velocity plots and pressure plots and all. Okay, so this is how we can able to deal with this particular model and the ANSYS Fluent analysis. That's all guys, thank you, stay tuned, bye everyone.